Everybody. I just wanted to do a really quick video on adding and subtracting integers, which is what the homework is on tonight. In class, we've learned several ways to add integers. One of those is with a number line. This was from our homework the other day, and I'm just going to model what it would look like on a number line. So we have the problem -4 plus -1. We've been working on integers for a while. We know that negative numbers are to the left of 0, positive numbers are to the right of 0. So to model this, we start with our first add-in, which is a -4. So to model that, we would start at 0 and we would go left to the -4, and we would draw our arrow showing that we were moving to the left, and this would represent a -4. Then to add a -1, we would stay where we were and we would continue to the left 1, which puts us at -5. -5 represents our sum, that a -4 plus a -1 is -5. What we used this for was for determining the rules for adding and subtracting integers, because with adding integers, models are great as long as the numbers are low, but we need to understand what's actually going on so that when the numbers aren't low, we still understand how to come up with -5. So we know that when we are adding integers, if the signs are the same, make sure y'all can see this. When the signs are the same, we simply just add them together. We add the absolute value of 4 plus the absolute value of 1 would be 5, and we know it's a -5 because both of our integers are negative. Now let's look at it when the signs are different. So here we have a +3 plus a -2. So we start at 0. Again, we do +3 first. That means we go to the right 3 units. That represents our 3. And to add a -2, we have to go back to the left. So we're at we're at +3, and we go to the left. That represents 2. And you can see that we end at 1. Because to add integers where the signs are different, where 1 is positive and 1 is negative, you subtract their absolute values. So we would subtract 3 from the absolute value of -2, which is 2. We subtract 3 from 2 and we would get 1. Now the 1 is positive because our largest absolute value, which was 3, was bigger. The way the kids and I looked at it in class is this distance, that's what absolute value is, from how far that number is from 0. This distance, 3, is bigger than this distance, 2. Therefore, I still have positives. That's why our answer is positive and not negative. Now, we also learned that we could model this with integer tiles. For instance, up here, we could say 4 negatives plus 1 more negative creates 5 negatives in all. They're all the same. So that's why we add them all together. But down here, 3 positives plus 2 negatives leave me with 1 positive, because what we call a zero pair, this positive and this negative cancel each other out. They're called a zero pair. So does this positive and this negative, which just leaves me with 1 positive. So the kids have been shown 2 different ways to model this addition of integers. You could use a number line, you could use integer tiles, but ultimately we use these to come up with our rules, that when the signs are the same, we add them together, and when they're different, we just subtract them. What kind of threw us for a loop last week was when we threw in the subtraction of integers, and here's how I explained it to the kids. I'm just going to come up here to the top of this paper. Now, we'll just get a new piece. So the kids know that if I had a negative outside of any number, and I'm just going to do -3, that the negative means the opposite of. So if I gave them this expression, they would know that this says the opposite of -3, which is a +3. And we could put a positive sign if we wanted to. What happens with subtraction is, since this is the same as a +3, we make our subtraction problems addition problems so that we can use the same rules that we already know. We just turn them all into addition problems. And we do that by using the additive inverse property and adding the opposite. So for instance, if I had 8 minus 10. 8 minus 10, I see that it's a subtraction sign, and I know that I could rewrite the opposite of 10 as adding a -10. Those are equivalent. We still have the 8 out here in front. Now that it's an addition problem, because subtracting 10 is the same as adding a -10, both of these move left on a number line. I haven't changed the problem, but now that I've made it addition, I can use the rules that we've learned before. So now, since 8 is positive and 10 is negative, I know that I have to subtract their absolute values. 10 minus 8 leaves me with 2. But I know it's going to be a -2 because I have more negatives than I have positives. So my negative distance would be longer than my positive distance. Here's what I mean by that. If I put it on a number line, 1, 2, 3, 4, 5, 6, 7, 8, and I go to +8, when I add a -10, I'm going to have to come back to the left. And see, that's only 8, so I have to keep coming 2 more to get -10. My negative distance is longer than my positive distance. So that is why my 2 is negative, because I end up coming past 0. These two parts cancel each other out, leaving me at -2. So when the kids are doing their homework, I'm fine for them to use number lines or integer tiles if they need to. What I want them to be able to remember is, when you come down with problems like these, 65 plus -20, we don't have time to draw 65 tiles. So we need to remember that since these signs are different, I would subtract them, which gives me 45, and I know it's going to be a +45 because I have more positives than I have negatives. They need to apply the rules, especially to these bigger numbers. But the homework tonight is not due till Wednesday. Y'all let me know if you need anything else. Have a great day.